Now we discussed about some series, and this is the progress of how we handle the subject. We started from infinite series, and then we discussed about convergence and divergence. Here we said the ones we are concerned about are the convergent series. And from there, from the convergent series, we were able to talk about power series as being form of convergent series, where we express a function in terms of the powers of x. Do you understand? Like this, power series will be in this form, fx, and it will be a x raised to power 0 plus bx plus cx squared plus dx cubed, like that. And later on, after working it out, we realize that this ABC, these coefficients are constant, which can be derived by differentiating fx and then substituting 0 in place of x for each of them in different levels. And this was worked out by Maclaurin. So he made the job very easy for us. And he said fx is going to be a, and that is f0 plus the first differential plus the second differential of the 0 x squared over 2 factorial plus, and it goes like that. So you can see the job becomes easier and easier, because at the end of the day, this is A, this is B, this is C, and it goes on like that. So from here, we have been able to work on some functions. We have been able to derive that sine x is equal to x minus x cubed over 3 plus x raised to the power 5 over 5 factorial minus x raised to the power 7 over 7 factorial. And it goes on like that. We have been able to work that out in the previous section. Now, from here, we can also work out cos x. And how do we do that? We can differentiate this term, or we can use Maclaurin series. In case you are not privy to this, you will not be able to work it out by differentiating this term by term. I'm just telling you. Like if you come to an examination and you are given this, express this in terms of the powers of x. You get sine x, you get cos x, you get tan x, and you get sec square x. You know, since once you can find this, you can get this by differentiating this one term by term. Once you find this, you can get the expression for this by differentiating the term of this in sequence. So that's what I'm saying. Now, invariably, we can get the expression for cos x by differentiating this term. So cos x will be 1 minus 3x squared over 3 factorial plus 5x raised to the power 4 over 5 factorial minus 7x raised to the power 6 over 7 factorial plus, and it goes on like that. Then, we can now see this to be 1 minus x squared over 2 factorial plus x raised to the power 4 over 4 factorial, because by the time you divide this, this 3 will go, this 5 will go, to remain 4, minus x raised to the power 6 over 6 factorial. So this will be cos x. I just open your eyes to see this. But then, I will still work it out using Maclaurin series, in case you don't know this earlier on. So you have to work it out using Maclaurin series, if that is the question you are asked independently. So let's see how it goes. Now, let's use Maclaurin series to work out expression for cos x. As we have said before, the x will be in rads, not in degrees. Now, so cos x will be equal to f o plus plus and to go on like that. Now, the main work here is to find these coefficients. And since we have known what it will be, we can start. Let's see coefficients. Fx is equal to cos x. So f0 is equal to cos 0, and that is 1. So let's keep record for this here. So fo is 1. Now we have this. So you can see. So I have minus. Sorry. I have f is minus 1. Now, the third differential will be sine x. So, will be sine 0, which is equal to 0. So, I have it here. You can see. So, let's go on to the fourth one. What's that? That is cos x. So, f for 0 is equal to cos 0, and that is 1. So, f4 is equal to 1. So, if you continue like this, if you continue in this perspective, let's see if you can add this one too. So, f5, and that is equal to minus sine x. So, f5 0 is equal to minus sine 0, which is 0. Is equal to 0. So now let us now substitute this in this expression and see what it will be. So cos x can be therefore is 1. So this one is 0 times x minus 1 into x squared over 2 factorial. And then 0 into x cubed over 3 factorial plus, I think that should be 1, 0, minus 1, 0. Okay. Plus 1 into x raised to the power 4 over 4 factorial plus 0 into x raised to the power 5 over 5 factorial, and it goes on like that. So at the end of the day, it's going to be 1, this one is 0, minus x squared over 2 factorial. This one also is 0, plus x raised to the power 4 over 4 factorial. The next one will be 0. And it means that the next one will be x raised to the power 6 over 6 factorial. The next one will be 0 again. So it means that the next after this will be plus x raised to the power 8 over 8 factorial. And it goes on like that. So let's compare it to this. 1 x squared over 2 factorial plus x raised to the power 4 minus x raised to the power 6. You can see. So it means that you have been able to get sine x cos x. Let's look at another one. That will be tan x. Now let's find the expression for tan x. So using Maclaurin, we can say this will be FO plus F3 so we need to find the FOs. Now if we say tan x is equal to fx, so FO is equal to tan O, and that will give us 0. So let's do it like this. Zero. Now, let's try to find fx, the fourth differential, and that's going to give us sec square x. So which means that f0 will be sec square x, and that is sec square 0, sorry, and that is 1. So f is 1. Then, to find the second differential, we have to differentiate sec square x, and that will be d dx 1 plus tan square x. You know, if we use product rule or function of function, we get it. So it's going to be like this. The first one is 0, and to differentiate this, it will be tan x sine square x. So this one is just going to give us tan x sec square x plus tan x sec square x. Just to make it simple. So it's going to be 2 tan x sec square x. That is how it is. Or you can use function of function, where you say u is tan x and y is equal to u squared. So dy du is 2u, and du dx is sec square x. Therefore, dy dx will be dy du dot du dx, which should be 2u sec square x. That is 2 tan x sec square x. So it makes the job very easy. So from now, you can easily use function of function. You can see that the major work in this standard series is differentiation. Now let's see. So if I can still make this one to be equal to, okay, let me find f2o. That will be 2 tan 0 sec square 0, and that is 0. So f is 0. From here, let's see again. What we need for this one now, f2x can be taken as 2 tan x into 1 plus tan square x, which is 2 tan x plus 2 tan qx. Now, to find f, the third differential is going to be 2 sec square x plus 2 dot 3 tan square x sec square x. I'm using function of function to differentiate this. Let's see how it goes. Say if I have tan cube x, u equals tan x, y equals to u cube. So this is going to be 3u squared dy du, and du dx will be sec square x. So dy dx will be dy du times du dx. So that is 3u squared sec square x, 3 times square x sec. So that's what I did there, multiply by the initial. So that's what I got there. So now, the third 0 will be 2 times 1 plus 6 times 0 times 1. So the third is equal to 2. Now, let's get the fourth. So let's complete this one now. I have this one to be 2 sec square x plus 6 times square x sec square x. Now let me express everything in terms of tan to make it easy. So it's going to be 2 into 1 plus tan square x plus 6 tan square x into 1 plus tan square x. So this is 2 plus 2 tan square x plus 6 tan square x plus 6 tan raised to the power 4 x. This one and this one gives me 8. So this is going to give me 2 plus 8 tan square x plus 6 tan raised to the power 4 x. Now if I want to get the fourth f4, I'm going to differentiate this. So this is going to give me 0 plus 8, and this is going to give me dot 2 tan x square x. So therefore, x is going to give me 16 times x sec square x plus 24 times cube x sec square x. And from here, I can easily get my f40. Putting 0 here, putting 0 here is going to give me 0. So f40 gives me 0. Now, I can still expand this so that it will be easy for me to get the fifth differential. So f for x will be 16 into tan x into 1 plus tan square x, okay, plus 24 tan cube x into 1 plus tan square x. So this gives me 16 tan x plus 16 tan cube x plus 24 tan cube x plus 24 times the power 5 x. So I have, let me make it like this, 24 times the power 5x plus 40 times the power 3x plus 16 and x. Now to get the fifth differential will be easier now. So I have f5x. Differentiating this, I'm going to have 24 multiplied by 5 times the power 4 sec square x. We have done this before. Plus 40 plus 3 tan square x sec square x plus 16 sec square x. So f50, putting 0 here makes this one 0, this one 0, and this one 1. So I have this one to be 16. So f5 is 16. So let me express it further. So f5x can also be written as 120 times the power 4x sec square x plus 120 tan square x sec square x plus 16 sec square x. So if I want to find f6, the sixth differential, I can easily do it now. But I'd rather I stop here because of the significance. So let's quickly work out what our tan x will be. So tan x will be equal to, what's f0 plus f1, that is 1, dot x, what is f2? 0 dot x squared over 2 factorial. f3, that is 2 dot x cubed over 3 factorial. f4, 0 dot x raised to the power 4 over 4 factorial. 5 will be 16 x raised to the power 5 over 5 factorial. And it goes on like that. So I can now express it as x plus 2x cubed over 3 factorial plus 16x raised to the power 5 over 5 factorial plus. So to make it easy to learn, it's better I leave it like this. So this is how we get the standard series. So I still work more in the next section. Thank you very much. Please keep tab and then share, subscribe. Let others also benefit from this. Thank you very much. See you in the next class.